Welcome back to Chapter 1 in Contemporary Geography. In our third lecture, we're going to be interpreting maps. In human geography, we use a spatial perspective to understand the world. We use spatial perspective while considering the relationship between known phenomena and individual places, including the relationship between humans and the physical world. Basically, we're searching for the why of where, and maps are our essential tool. Consider the importance of maps for the 5 themes of geography. 1. Location. 2. Human-environmental interaction. 3. Region. 4. Place. 5. Movement. In order to use maps effectively, we need to understand map scale and map projection. Map scale. The level of detail and the amount of the area covered on a map depends upon its map scale, which is the relationship of a feature's size on a map to its actual size on Earth. In the unit scale of the USA map, we can see what unit represents 300 miles. This graphic scale consists of a bar line marked to show the distance on Earth's surface. To use a bar line, you have to first determine with a ruler the distance on the map in inches or centimeter, and then you can hold the ruler against the bar line and read the number on the bar line opposite the map distance on the ruler. Map scale can also be shown as a ratio, such as 1 to 10,000. Some maps use a written scale to describe the relationship between the map and Earth distances in words. For example, 1 centimeter equals 10 kilometers. Okay, let's talk about projection and turning a round Earth into a flat map. It ain't gonna be perfect. Here's what 4 commonly used projections do as shown on a human head. Here's the distortions. The shape of an area can be distorted so that it appears more elongated or squat than in reality. Or the distance between 2 points may become increased or decreased. The relative size of different areas may be altered. The direction from one place to another can be distorted. The choice of projection depends upon which of these 4 distortions are most important to the map user. For example, you would not use the Gauss-Peters projection if you need the shape of land masses to be undistorted. However, you might want to use it if you want to make your particular continent look bigger. Projections. Earth's spherical shape poses a challenge for cartographers to make flat maps that are not distorted. Transferring locations on Earth's surface to a flat map is called projection. One of the many attempts to produce low distortion maps is the Mercator projection. Do you think Greenland is really bigger than South America? So we have already seen the Mercator projection has a little distortion of shape and direction. Its greatest disadvantage is that relative size is grossly distorted, making high latitude places near the North and South poles look much larger than they actually are. Gauss-Peters projection. In contrast with the Mercator projection, it doesn't distort relative size, but does distort shape. The Good Homolocene projection separates the eastern and western hemispheres into 2 pieces, a characteristic that's known as interruption. The meridians, which are the vertical lines which in reality converge at the north and south poles, do not converge at all on the map, Also, they do not form right angles with the parallels on the horizontal lines. The Rubenstein projection is useful for displaying information across the oceans. Its major disadvantage is that by allocating space to the oceans, the land areas are smaller than on interrupted maps of the same size. Here's a freak out to orient, meant to put east on top of the map. Ptolemy changed that. Take a few minutes to check your understanding of what we've learned so far. Can you compare and contrast geography and history in terms of what geographers and historians do? Can you summarize geography's 5 most basic concepts? Can you trace the development of geography in the ancient world through the Middle Ages to the Age of Exploration? How about can you identify contemporary analytic tools of geographers, including remote sensing, GPS, and GIS? Can you describe the role of volunteer geographic information and mashups in contemporary geography? I hope now you can explain 3 ways of representing scale on a map: ratio scales, written scales, and graphic scales. Are you able to discuss how map projections are used to solve the problems of distortion in flat maps? It's always a good idea to review your material and make sure you really got it. Hey, coming up next, the geographic grid. Latitude and longitude, locating points on Earth's surface, how we use longitude to establish time zones, and the historical search in England in the 1700s for a way to measure longitude accurately. Until we meet again, study hard and enjoy this glorious world. Ta-ta!